Hi, good afternoon or good morning. We want to welcome you to the second part of our three-part series on advanced turning. Today we're going to be going over Swiss programming, and I'm very thankful to have Christian Peluche joining us from Autodesk. From our team at NexGenCAM, Phil Jennings is joining. Both of these guys have a tremendous amount of experience and have been a joy to work with and work with customers on these complex machines and to have some great results. My name is Eric Strassheim. I'm one of the directors at NexGenCAM. And we just want to thank you for spending some time with us. This webinar we've designed to be very quick. We're going to go through complex topics, but in some cases, we'll provide more information for you to dig deeper. And obviously, you can always contact us and our team to go over things that are more particular to your machines and the type of work that you're doing. I wanted to start off by just going over the Autodesk manufacturing portfolio. It is pretty amazing the amount of investment that Autodesk has made and how they've been expanding in the market. You look at this from the planning side of some of the innovation they have around how people are designing new parts today in auto and aero. You get into some of the programming, obviously, which is our sweet spot with the CAM solutions, that they have a very impressive lineup. And then getting into producing things on the far side in terms of building stuff and using things in robotics and fabrication and that side of it. It's a very excellent lineup, and I know bringing this to market is a great joy for us and our team, just to have the breadth of this to be able to help in different areas. One thing that's new, if you're not aware, last Monday, October 5th, Autodesk also announced another acquisition in this space, acquiring CAMplete Solutions. If you're not aware, this has been a verification and simulation software that's very well thought of. These solutions they go directly from the CAM to the machine, and so sometimes you wouldn't need a post-processor and provide even a higher level of fidelity. Anyway, just very impressive for us to be working with Autodesk and see them continue to invest. I know, Christian, we've got you on the call here. What are your thoughts around this? I'm sure everyone at Autodesk is very excited.
Yeah, Eric, we're very excited over here at Autodesk, and just how CAMplete's technology is going to help us continue to grow our manufacturing portfolio.
Yeah, fantastic. My hat's off to you. Great job to the Autodesk team. So these numbers are now outdated with this additional acquisition, but Autodesk is ranked the #1 investor into this space. When you look at 600 software developers, experts, and consultants, it is the largest team. You look at the solutions that have been purchased is over $1 billion. One of my favorite things is that Autodesk is also looking to the future. They have these innovation centers they've set up around the world. If you're ever taking a trip to San Francisco, you've got to go right down on the pier, right off of Market Street. They literally have a machine shop sitting on the edge of the bay, and I don't know how they do that legally. I hope nobody ever spills any coolant into the bay there. They would have a huge fine, I'm sure, but it's a neat place, and it's open to customers. They also have a kind of a museum there of all the creations that their customers have done. There's also an innovation center out in the bay on Boston as well. If you aren't familiar with NexGenCAM, I just wanted to go over this briefly. Obviously, you guys could call us. You could contact us. A lot of this information is on our website, so you can click. It's there at the bottom and learn more about us. We've been Autodesk's #1 CAM partner for 5 of the last 6 years. And the reason we've done so well is because we have a lot of experts. It's our team. It's our people. All the technical experts on the team have not only run CNC machines and been in your shoes, but also know multiple different softwares and have a great experience in how to solve and meet the needs that you might have. We're an Autodesk authorized training center. It's amazing just how much training we have going on. If you want to see just the standard classes, you can go to our website. There's a calendar in there, and you can see the dates, the times of all these classes. It's really amazing. You look at, we can really support anybody in these processes, kind of soup to nuts on the services. 2 areas that are kind of unique. We can do turnkey robot systems. So from a standpoint, if you want to put a milling head on the end of a robot, some neat things like that. We have a couple different brands in here. Programming Plus is our programming team. The robot I just mentioned is a team. We have a partnership with Robotic Solutions. It's up in Wisconsin on that front. We're also nationwide, so we have a nice diverse group. We're in the West, we're in the Central, we're in the East, and meeting the needs of a lot of folks and kind of covering all the Autodesk CAM solutions all the way from Fusion over to PowerBill. Here's the agenda that we have for today. We're going to start off just digging into some of the key technologies in turning around Swiss that make it so exciting. What we're trying to do is to make it easier to use these complex machines with a lot of operations, and by going through some of these different areas and showing you what is possible. We're really only going to scratch the surface in 35 minutes. I'm going to go through a few of the slides in here. In the second half, we're going to get in a little bit more to the ease of use. How is it that these programs can make your life just easier and make the machine and learning how it moves, all of that just a little bit easier. First topic I wanted to hit was broaching. And there's 3 types of broaching that we're working on: rotary, punch, and nibble. And knowing we can't cover everything in here, if you're doing broaching, we have a basics video that we just uploaded this morning. You can go up at 6 minutes 51 seconds on our YouTube channel. And thankfully, Christian, nice job, put this together to just go over the basics of this really quickly for you to see it. And then on the higher end, getting into more complex stuff, there's a great video up here that Brian Denola put together. It's done together with Jen Swiss and Tsunami Rem Sales. And you're kind of bringing some really good people together to talk about broaching and the capabilities on the Tsunami that's on the screen. There's another video that you can go and catch. On pinch turning, there are some different videos that we have that you can watch on this as well, but there's 2 different operational methods in here. And it's just something you've got to be able to do at the high end of turning, and it's certainly something that's in our packages. It's also included in the feature cam solution, which I'm showing up here, is a little bit of pinch turning, but it's also in the part maker solution as well, and kind of rounds out our whole solution, if you will. So moving into thread whirling and milling, I think I did mention this earlier, but you can go to our website. We do have some of these videos and some of the stuff in more detail shown there. But PartMaker has the ability to do the thread milling, the thread whirling in there, and also creating thread milling whole groups and profiles. So these are nice capabilities. We'd love to go through it in more detail with you, look at the type of parts that you're making, and see how best we can help you. Getting into B-axis milling and laser machining, I love the demonstrations where we cover this stuff and go into it. So it's going to be great. We're going to have Christian going through some examples with 2 different parts. I think the second part will be on this B-axis milling and go over it for positional and simultaneous. On the laser side of things, this was added maybe just a couple years ago into PartMaker. We noticed a lot of the new machines are coming out with lasers. We've been adding it into the post processors. There is, if you go to our YouTube channel again, there's a very basic video on laser machining that will take you through this. One thing, especially if you're a current customer, we do have a huge manual written for PartMaker. I mean, it's massive. We have to send out a link because it's such a large file that you can go through. If you don't have a copy of that, send us an email, contact anyone from our team. We can get you a copy of this manual. And we've got this newer manual that does have a section in there on laser that would be accessible to you. Another good one here, just going into polar and cylindrical milling. When you look at these solutions and you're looking at the mill features that can be done, it's just a lot of complex stuff being put together in here. Wrap toolpaths is a request we get a lot from people, and it's nicely done in this solution. And then looking at helical entries is going to be covered in the second half of this next upcoming demonstration. So with no further ado, let's get into the actual fun part of this and look at the technology.
Okay, so on this part, we're going to be taking a look at 3 different operations within PartMaker: thread whirling, we're going to take a look at cylindrical milling, and then lastly, we're going to take a look at polar machining with a Z-facing tool. So to start off, let's take a look at this thread whirling operation. As you can see, it's an odd-shaped thread that would require a custom tool shape. So if I go ahead and create a turn face window and a new profile group, I have the option as a strategy to pick from a thread whirling strategy. In here, the parameters are fairly simple. We have the thread height, the pitch, and then we have some options as far as whether we want to ramp in or out. I have those set to 0 here. If we look at our edit tool dialog and see how we actually have the tool defined, we have a user defined tool shape. So we have a custom thread insert, and we have that set up 3 times around the part. So we can see that using our shape preview here. Now we can also set this thread whirling unit at a slight angle if we'd like. I have it set to 0, but if it's at a couple degree angle, then we set that as our edge angle. I'm going to go ahead and apply and close that. And let's just take a look at the profile itself. So for a thread whirling toolpath, you select it off of the major diameter, just the same as you would with a standard threading operation. So I'm going to go ahead and pick some points that I have defined here, and then we can actually use the angle here to get out of the thread. And then that will eventually meet back up with another thread whirling operation that we have, and those are overlapped by a pitch, which is why you see this grid that we have here. Those are just increments of the pitch. But in short, that is the thread whirling operation. Simply just select the thread whirling strategy from a turn face window, and then set your tool parameters as you have it set up on the machine. Next, let's take a look at the cylindrical milling within PartMaker. And first thing, we're going to open up the setup dialog, and we can see here that a mill cylinder face window is the correct face window for any sort of cylindrical milling. And what we're doing there is just unwrapping the part into a flat surface, and then we're going to take our profile group and rewrap it around the part. So to do that, let's just take a look at these stripes that are around the part. There's 3 of them here. So we'll quickly go through and recreate this the way that it was originally done. So we can just delete the geometry that's in here, and then let's go ahead and select the surfaces. And then since we're in a mill cylinder face window, when we extract that geometry and project the outline, it's going to project it onto a flat plane here that will later be wrapped around the part. As you can see, the geometry of the part has been unwrapped. So C0 being at the center, C minus 360 at the top, and positive 360 at the bottom. If I go back to my CAD side, we can draw a line that will just run down the center of this. And to do that, I'm just going to measure a couple points here. That gives us about 50 thousandths. And then we can use the parallel element icon and say 25 thousandths from that top line. And then I will use my trim extend icon to bring us to the back of the part here. So that gives us the line that we're actually wrapping around the part. We'll go ahead and just select that profile. But before that, let's just take a look at the strategy that we have here. So this is going to be a contour mill strategy with tool position on. So just on center of the line that we have drawn. To select the surface and depth, we've done so directly off of the model. So if I say extract parameters from solid, I can pick one of these stripes here, hit extract, and that gives us the X surface and X depth. We have a 60 thou ball mill selected, and let's go ahead and just pick the profile. So we'll just use the define profile icon to select those 2 points right there. And now we can see that that profile has actually been wrapped around the part. Now, if we want to copy that, there's 3 total on this part. We can just select the profile itself, go to edit, transform, translate, and then we'll add a couple copies. So 2 more copies at 360 divided by 3 degrees in the vertical distance, and hit translate. And now we have 3 wrapped around the part. When I go ahead and actually single step through here, you can see the part rotate, and then we have our toolpath. Okay, so lastly on this part, we're going to take a look at some polar milling on the back of the part. So if we go to this hexalobe face window, we'll go to the setup dialog. You can see for polar machining, we're going to use the mill end polar face window, and that's going to take any kind of Y coordinate and that turns it into C coordinates. So in this case, we're doing that on the sub spindle. To come up with the geometry itself for this, we would do that the same way that we would any other type of milling within PartMaker. So if I delete that geometry, I can delete the toolpath itself here, and then we'll just pick the surfaces off of the model that we want to project up top. And then we will convert curved edges to arcs. And then now we have a profile that we can actually select. The toolpath itself on this part is just going to be a contour mill, left or right, left being climb mill. Now to get the actual depth on the model itself, we can extract parameters from solid, and then I'll click the top surface, hold shift, select the bottom surface, and hit extract, and that gives us our Z surface and Z depth. And then let's go ahead and just select the profile itself. So being that it's a left toolpath, we want to change the direction. I'm going to hit reverse, and then we'll go ahead and verify the toolpath. So it looks like our lead in and lead out is not working how we would like it to. So let's go ahead and change the start point. Now the start point can be just done by selecting a different point off of the model. So if I select that point and then we'll verify again, it looks like we will need to actually modify our lead in and lead out a little bit. So just for this example, we'll go ahead and change those to 0, and we'll see how that works. And that looks a little bit better. Now we're not cutting into the edges of the part, but we could modify the lead in and lead out to actually come to the center if we choose to do so. Now, for this example, what we have the tool doing is stepping down. If instead we preferred to do a helical motion using our C-axis, we can open this up, and then I'm going to turn on the Advanced Milling Toolpath checkbox, and under Advanced Tool Entry, we'll go to Follow Toolpath and do a max angle of 1 degree, and apply and close. And then actually the last thing before that is to set our axial step to 0 so that we're not doing any passes downwards. We're just using the helical motion. So let's go ahead and single step forward. And then now we can see if we play through that it's going to do a helical motion all the way from the top to the bottom of that polar machining operation. In this example, we're going to take a look at how to mill a 5-axis feature or a B-axis feature onto a part within our PartMaker SwissCam. So the first thing that we're going to do is go to our setup dialog, and we're going to create a new face window. In here, we will choose the mill 5-axis plane. I'll call that mill 5-axis. And we'll hit apply. Now there's a few ways that we can actually go ahead and create the B and C angle as well as the local coordinate system. If we go into face options here, we can manually do that, adding our B and C as well as our local coordinate system. Alternatively, we can utilize the model itself. So if I select this surface here and then I select define face plane, it's automatically going to put our local coordinate system of that face plane on our feature that we selected, as well as setting the B and C angle of it as well. So we'll say OK. And then if I click on view normal to face plane, now we're going to be looking straight down at that feature. For the size of this flat, I'm going to use an 1/8 inch end mill. So if I select a new profile group, I can just say we'll do an on-center contour mill. I'll search my tool database for 1/8 inch end mills. And we're going to want to pull up a Z-oriented tool anytime we're using the B-axis. So we'll go ahead and say select. We'll verify in our tool that it is actually oriented in the Z direction. And we'll say OK. So we'll call this mill flat and hit apply. Now just to verify, if we extract parameters from the solid, and click on that face, we will get a 0 depth and surface because that's where our face plane is currently located. So that should be correct for us. So we'll say apply and close. And then I'm going to go ahead and double click on this feature right here and transfer that up into our 2D window. If I go ahead and select the define profile icon, I'm going to select these 2 points here, and we can verify that toolpath on the solid itself. So let's go ahead and press single step and click through this, and that looks like a good toolpath clearing off that flat. Now we can also do drilling just the same way in our B-axis planes. So if I select a new hole group and we use extract parameters from solid, I can select the inside of that hole, hit extract, and then add a new cycle for this. So in here, it looks like it's a 40 thousandths drill. We're going to insert an operation and do a spot drill with spot face, and I'm just going to pull up an 1/8 inch spot drill for this. So let's go ahead and select tools. We'll add a new one for our spot drill, and that's going to again be a Z tool. And then again for the 40 thou drill itself in the Z direction. Okay, so we'll say apply. And then before we exit this dialog, we're just going to change the spot drill hole diameter size to match what it's actually putting a chamfer on, which is a 40 thou drill. So we'll say apply and OK. And then the software itself already pulled the chamfer size as well as the depth, so we can apply and close, and then use the single hole on solid model icon to select our hole. And we'll go ahead and single step through and verify this toolpath.
Thank you, Christian. It's always fun to watch those and just see the parts spinning and, you know, all the different options that are available, which is so important to make sure that you can match the capabilities of the machine into the software. In the next demonstration, we're going to go over this and show it, but the process table is really the key area that makes PartMaker really unique. This is a purpose-built tool. It was originally built to run on Swiss machines, and you start to see that here, that we're kind of taking something complex and making it easy with this process table. So if you look in part A, it's just get all the operations in there, all the things that you want to do. And then in part B, we're looking at, okay, am I utilizing my different spindles, and am I moving the part around? And then literally, this is where you drag and drop and you move stuff. So if you're doing Swiss today and you're doing cut and paste, you know, a lot of people are cutting and pasting codes from different areas and try to put them together. This is like your, you know, the replacement of that. This is, you know, without all the cutting and the pasting. You can go in here and you can experiment, you can move things around. And as you do that, it's showing you the cycle times down below. This is so key because you can do it offline and you're not necessarily utilizing the machine. This here part, which is kind of a patented part of PartMaker, is what makes it so good. I was talking to a president of a medical company, and PartMaker is used extensively in the medical space, and just was going over this with him. He was just talking about how this one table has really dramatically changed the way that they work. You know, you think about it, if you're running a Swiss machine, you're doing a very much a linear programming. You're piecing things together and trying to encapsulate everything that's going to happen. And the moment you've got to change something, you have to go back and start linearly and do this over again. People that get proficient with PartMaker, you know, kind of changes the way they think about it. The first thing they're doing is saying, hey, what machine am I running this on? I want to get the best toolpaths for that machine and just get them on the part, throw them into the table. Then I start to move things around and choose the best order of operations to get everything done. The nice part is you don't have to check all those transitions. PartMaker's doing all this for you. All the transitions are going to be handled. And if there's an issue, this table is going to let you know. The visual synchronization that's in there is very helpful. We're going to go over this example with this part, and it's going to allow you to do kind of, you know, complex combinations of things very easily. We support up to 4 turrets and 2 spindles, so bring the complex machines on and let us know what you've got in turning, and we can sit down and work with you. Speaking of complex machines, the heart of this solution is the post-processor system that's been built. We have over 900 proven post-processors, and some of these are for, there's multiple different versions depending on what they are. I just took a list of all the manufacturers that are listed in here and just threw this up as and I may have missed one or two in here because I did this kind of quickly, but just a ton of work has been put into these. And if you know the effort that goes into getting these to really work, this is kind of a work of art that's been put together here. I know we encounter a lot of people, and they'll say, well, I have a Swiss software that can run my machine or that I've purchased. And a lot of times that means that, no, they've done a lot of work on one post-processor for one of these machines, and now they're marketing it as a Swiss solution. The other thing is these are open, so they're not necessarily locked. It means you don't just get the best post that everyone in the community gets. You can get one that you can edit and you can change. And Christian, you were around when they were building all these and been a part of that. Obviously, we're still building new ones. What are your thoughts on this, the post-processor engine?
Yeah, like you said, Eric, I was sitting next to a lot of these guys as many of these posts were being written, and it just took tons of work and an incredible amount of knowledge in the Swiss and multi-axis industries to be able to get all this done.
Yeah, it's amazing. I know, even I was just looking at one on here, the index machines, the Trobs are based, they have a big shop here, or office here in Indianapolis. It's just amazing to go over there and see these amazing machines and then think that, hey, we can actually help you with those and make it better. Okay, at this point, we're going to move in, and Phil, I'm going to hand it over to you to go ahead and go through this.
Autodesk PartMaker SwissCAM. This allows the programmer to quickly and easily create toolpath strategies for their Swiss programming machines. With the use of our predefined construction planes through the Setup dialog box, we can quickly and easily create construction planes for working around the part when we need to create the features. Once the toolpaths have been created, we then generate our process table. The process table in PartMaker is a very, very handy tool. In the process table, we will list the toolpaths that you've created, the tools that you're using, and also the right side of the screen, the synchronization buttons that you can use to synchronize toolpaths together, whether you're doing two tools on the main spindle, a tool on the main spindle, a tool on the sub-spindle, synchronizing both together. PartMaker makes that process very simple. If we need to reorder operations, we can do that easily as well. For instance, my spot and drill on the face of the part, I am going to do right after my first turn. So I just grab the tool paths and stick them where I need them. On the right side of the page is our synchronization options. This is PartMaker's visual synchronization technique. You can actually read through what you're trying to accomplish on your machine. For instance, in this case, I'm machining with one tool on the main. If I want to be machining with one tool on the sub, I simply let the system know I'm machining with one tool on the sub. And if I want all the main processes to do the same thing, I can modify the mode for all the consecutive processes. And you'll notice that on the right side of the screen, the system is now showing the main spindle and the sub spindle looking at each other, or working together, if you will. The sub side is the exact same thing. I pick my first sub operation. I tell the system that I want to machine with the main spindle as well while I'm working on the sub. I'll do that for all my sub operations. Select OK, and I now have my tool paths synchronized together. The cutoff process, I'm going to support that process. Put in the grip length, synchronize the tool paths together, and now I have a tool path completely synchronized between the main and the sub spindle. Using our full machine simulation, I can verify and simulate the toolpath work. And remember, in this case, this synchronized state is one of the easiest to create. We're just mainly using the main and the sub spindle to do the work at the same time. we can create many more complex synchronized states. And as you can see here, once we pass off the tool to the subspindle, the main and the subspindle will be working together. As you can see, I'm using both the gang and the turret to machine the flats and the pockets. At this point, the system will start working together. And as you can see, I've got a simple synchronized tool path. The synchronized states in PartMaker can be much more complex than that, though. Let me call up a quick example of using the gang and the turret together, and then synchronizing the rest of the tool paths so that once the gang and the turret finish their work together, then the system will go into a synchronized state. This particular process table, as you can see, I've got multiple sync states going on here. The first sync state is the main spindle and the subspindle working together. The subsequent synchronized states are two tools working on the part at the same time on the main spindle. And since I have multiple pockets, this is going to be a very efficient way to machine the part. Once again, using my full machine simulation, I'll rotate the simulation into a view where I can see everything working, and we'll go ahead and run this. And as you can see, I'm using two tools on the main spindle. Once that operation is finished, I will pass it to the sub side. And the machine is now in synchronized mode. Once the part is finished, I can stop the simulation, reset it, and show finished part. And here's your finished part. At this point, we're ready to generate some code. So all I need to do, set up my post options the way I want to see them. Select OK, generate the file. And let's view the NC program. So there it is. With PartMaker SwissCAM, your Swiss programming capabilities will be exponentially expanded.
All right, thanks, Phil. It's just great to watch that with all the simulation coming together. It looks like there was a processor there where it was just a little bit slower, but fantastic work just to see it all come together. So just an overview of this solution. You know, you think about there's 5 different steps that you're going to go through with a Swiss machine in order to get your parts, high quality parts, done quickly. The first is the CAD space. So we've got a CAD solution that's included with this solution. And the other thing that's nice is the moment you pull something into PartMaker, it's instantly kind of giving you a lot of the data that you want to instantly interrogate that model and see if it's going to be something that will work. We know a lot of CAD models that you get are not exact, and you've got to do a little bit of work on them. So at that point, you pull it into the CAM system. The nice thing about PartMaker a lot of people really like is you can combine 2D, 3D, or a combination of those together to get exactly what you want. The strategy that we have in CAM, which I mentioned earlier, is just get all of the operations on there. So that's what you see in the top level here, is just let's put all the operations in there. Some people aren't aware we share some of the same milling kernel with PowerMill, so you've got a lot of capability here from the milling side as well. And so the CAM is all about just getting them in there. And then back to this process control. Experiment, drag and drop, reduce your cycles. This is where we make it easy with this purpose-built tool and solution. And then we move on to what Phil had just showed us, which is, hey, let's actually simulate this. And isn't it nice to be able to look at it without all the coolant in the way and the machine moving and trying to peer around corners? You can turn things on and off and really view and see what the machine's doing. I know for people that just have bought a new Swiss machine, this can be good to have the simulation to help you just to see how the machine moves and get orientated. And I know for a lot of you that know Swiss and you just know it really well, at some point you aren't using this at all. You're just looking at the code, and you've come to a point where you're trusting PartMaker after using it, and you're just having a good experience. Lastly, all the documentation that comes back with this, I put this note in here, get your weekends back. If you have a split where you're the programmer and you're sending it out to the machinist, this is a great solution. This can also be customized, but you can get all kinds of data out to your team so that they can have confidence to move ahead with the programming. So just in summary, we've got one more slide after this. We've gone over Swiss type lathes and the solutions that we have to meet them. These are tremendous machines, fantastic. We know there are a lot of them being bought in industry, and there can be some stress and a lot of risk in these machines. And what we're doing and showing you here today is how we can reduce that risk for you in your shop. We can help you to program parts faster with more confidence, reduce the number of errors that you've got. And I think this last bullet is also important, is people are always looking for a way to have higher margins. And if you can do smaller runs or more complex parts, this is where we're kind of enabling you in this process with this solution. So in summary, at the end, this is the second part of a three-part advanced turning webinar series. We will be going over, I think we'll just get a pretty neat, the same time next week, manual programming. So we're going to go over how do our solutions help you with your manual programs, and then also what are some things you just should never do in manual programming. It just would take too long. So tune in for the next webinar. You can explore our turning capabilities. We have a turning page on our website. Most of all, if you're captivated and interested in what you saw today on the screen, call us. Almost every review, we're looking at your specific parts, your machines, and helping build a solution for what you need. If you haven't signed up on our social sites, you can also do that on Facebook, on YouTube, and you can see some of the content that we've been putting out. We also have a large number of training classes that are going on, and we look forward to hearing from you. I want to thank you all for joining for our webinar today, and wish you a good rest of the day.